All right, so this is for if you missed Zoom class on October 6th, Tuesday. So these are the three announcements that we talked about in class. Mainly if you're missing any assignments or you would like to retake any quizzes, you can always do so. And I would highly recommend it, especially if you have anything below a C minus. This Friday on October 9th, I'm going to make phone calls and send you an email if you have a grade that is below C minus. Friday of this week, in the email, I will detail 3 things to prioritize to demonstrate mastery of whatever you are missing and to also improve your grade. Right? So if you're watching this right now and you're like, Ms. Kwan, how do I figure out what my missing assignments are? Well, if you log into your Schoology page, on the right-hand side where it says upcoming, go ahead and click on the link that says make up missing assignments and retake for medical chemistry. And if you click on that, I left you a message, and down here are links on how to check your grades via Schoology and make up missing assignments. Below that is how to retake quizzes, and here's also a link for your quiz corrections retake doc, conveniently placed. All right, so hopefully that helps you in terms of figuring out what you need to do or figuring out what assignments you're missing or incomplete on, so on and so forth. So because today is a Tuesday, we mostly reviewed radioactive isotopes that we learned on Monday. Right, so if you feel automatically ready for the launch, go ahead and go back to your Schoology page, October 6th Zoom class links, and the link to the launch is located here. Right, if I click on it, it looks like this. Right, so you can use that to go ahead and start. There were a couple of things that I did want to mention before you started that I noticed that a couple of people got incorrect. So I'm going to summarize what we went over in both periods 1 and 5, just to make sure that we're all clear on everything, right? So some people were confusing this way of writing, right? So this is our isotope name or the name of our elements. And know that at the end of the isotope name, when I write dash and a number, the number is referring to its mass. Right? Sometimes you'll see it written like this. We've also shown this before. So this number 18 is also the mass. So whether it's written this way or it's written this way, this top number is the mass, this number is the mass, this represents the mass. And just as a reminder, this bottom number is the number of protons. Right. So I also asked the class a clarification question, and I asked them to tell me what type of radioactive decay this is. Right. So if you recall from the previous lesson, we learned about 3 types of radioactive particles or types of radiation that we're going to mainly focus on in this class. Right, and you definitely need to know these. So if you didn't have them on your notes from Monday, make sure you have them. 3 types of radioactive particles. All right, so the first one we talked about was 4,2-He, basically a helium nucleus or alpha decay. The second one we talked about is essentially an electron or beta decay. The third one is the Greek symbol for gamma. It has no mass, no protons. It's the smallest or highest energy, right? Gamma decay. Right. So one of the questions I might ask you in the launch is to let me know what type of radioactive decay is shown below. So it's got to be one of these three. So a question was asked on how do we figure this out? So if you recall, in the top row, you have your top number. Think of it as one equation. Change to a more visible color here. All right. So if the total mass of Ti is 48, it's going to break apart into two particles, right? So this might seem kind of confusing. Right, so let me draw it slightly differently. So if I start out with Ti, it's going to break apart because it's unstable. And one of the things that it's going to release is one of the three types of radiation. And whatever's left over is going to be what we call our daughter isotope, right? So in this case, it's still Ti, which might give you a clue as to which one it is. Right, so when I say radiation, I'm talking about these radioactive particles. It's going to be one of these. Right, so let's figure out the top row. So looking at the top row, since I start out with one thing and then it just splits into two things, if I want to figure this out, well, these two things need to add up to the thing that was originally, right? So 48 plus whatever this is should equal to the mass of 48. 48 plus what equals 48? Well, 48 plus 0 is 48. So I know my top number is 0. So if I know the top number is 0 or the mass number is 0, I know it can't be alpha because alpha has a mass of 4. So it's either got to be beta or gamma because it has a mass number of 0 for both of these. Let's do the bottom row and see what we get then. All right, so just like before, I have an atomic number of 22. And since this Ti just splits up into these two things, everything to the right of the arrow needs to add up back to the original, right? So 22 plus this thing should go back to 22. Well, 22 plus what equals 22? Well, 22 plus 0 equals 22. Aha! So I should notice that my mass number or my top number is 0. I should also notice my number of protons or my atomic number down at the bottom here is also 0. And I should look on this side and notice that, hey, the only particle that has a mass of 0 and 0 protons is a gamma particle. So this must be gamma. Right, so now I know this has to be gamma. Why? Because top number is 0, bottom number is 0, and of all the three radioactive particles we talked about, the only one that has 0, 0 is gamma decay. All right, so once you do this stuff, you should be able to do the launch on your own, and then email me once you complete this if you're completing this late, so I know to check back here. If not, I usually try to check back on when progress reports are due, which is next week. So the sooner you let me know by email, the better. All right. Email me if you need any help too.